The universe is filled with mysteries, and there are some secrets which are beyond human understanding. One such monstrous entity in space is called black hole. A black hole is a region of space-time where gravity is so powerful nothing can ever escape. Not particles, not electromagnetic radiation, not even light. In recent years, NASA instruments have painted a new picture of these strange objects that are, to many, the most fascinating objects in space. Not to mention the massive black holes found within our galaxy. So, let's talk about them. Welcome to Space World. In today's video, we are going to talk about a hidden trove of massive black holes found by astronomers. So if you want to know more about it, then stay with us until the end of the video. The idea of an object in space so massive and dense that light could not escape it has been around for centuries. Most famously, black holes were predicted by Einstein's theory of general relativity, which showed that when a massive star dies, it leaves behind a small, dense remnant core. If the core's mass is more than about 3 times the mass of the Sun, the equations showed, the force of gravity overwhelms all other forces and produces a black hole. Scientists can't directly observe black holes with telescopes that detect X-rays, light, or other forms of electromagnetic radiation. We can, however, infer the presence of black holes and study them by detecting their effect on other matter nearby. If a black hole passes through a cloud of interstellar matter, it will draw matter inward in a process known as accretion. A similar process can occur if a normal star passes close to a black hole. In this case, the black hole can tear the star apart as it pulls it toward itself. So, as the attracted matter accelerates and heats up, it emits X-rays that radiate into space. Recent discoveries offer some tantalizing evidence that black holes have a dramatic influence on the neighborhoods around them, emitting powerful gamma-ray bursts, devouring nearby stars and spurring the growth of new stars in some areas while stalling it in others. Talking about their location, black holes are thought to reside at the center of most galaxies, including our Milky Way, holding important clues to the functioning of these giants. A group of researchers has now found a previously overlooked trove of massive black holes in dwarf galaxies. Black holes are usually detected when they actively grow by consuming gas around them, which makes them grow intensely. These black holes, the researchers believe, can offer insights into the journey of the supermassive black hole that sits at the center of the Milky Way. The research conducted by astronomers of the University of North Carolina Chapel Hill Department of Physics and Astronomy, U.S., is expected to shed light on the origin of our galaxy's supermassive black hole. As a giant spiral galaxy, the Milky Way is believed to be formed by mergers of several smaller dwarf galaxies. But whether all dwarf galaxies contain a massive black hole is still unknown. This has led to a gap in our understanding of how black holes and galaxies grow together. The research published in the Astrophysical Journal recently helps fill this gap. It says that massive black holes are many times more common in dwarf galaxies than previously thought. They were, however, difficult to detect because the radiation from massive black holes in dwarf galaxies competes with the light of abundant young stars. This result really blew my mind because these black holes were previously hiding in plain sight. Magda Palomera, lead author of the study, and a UNC Chapel Hill PhD student said in a statement, for example, the Magellanic clouds seen in the southern sky are dwarf galaxies that will merge into the Milky Way. Each dwarf that falls in may bring with it a central massive black hole, tens of hundreds of thousands of times the mass of our Sun, potentially destined to be swallowed by the Milky Way's central supermassive black hole. Comparing black holes to fireflies, UNC Chapel Hill professor Sheila Knappen, who is also the co-author of the study, said that we only see black holes when they light up, just like fireflies, and the lit-up ones offer us an indication of how many we can't see. So, if we cannot see black holes through telescopes, how did scientists detect this trove of black holes? Black holes are typically detected when they are actively growing by consuming gas and stardust swirling around them. which makes them glow intensely. The problem is, while growing black holes glow with distinctive high-energy radiation, young newborn stars can too. Traditionally, astronomers have differentiated growing black holes from new star formations using diagnostic tests that rely on detailed features of each galaxy's visible light when spread out into a spectrum like a rainbow. The path to discovery began when undergraduate students working with Canapan tried to apply these traditional tests to galaxy survey data. The team realized that some of the galaxies were sending mixed messages. 2 tests would indicate growing black holes, but a third would indicate only star formation. Previous work had just rejected ambiguous cases like these from statistical analysis, but I had a hunch they might be undiscovered black holes in dwarf galaxies, Canapan said. She suspected that the third, sometimes contradictory test was more sensitive than the other 2 to typical properties of dwarfs, which include simple elemental compositions, which is mainly primordial hydrogen and helium from the Big Bang, and their high rate of forming new stars. Study co-author Chris Richardson, an associate professor at Elon University, confirmed with theoretical simulations that the mixed message test results exactly matched what theory would predict for a primordial composition, highly star-forming dwarf galaxy containing a growing massive black hole. The fact that my simulations lined up with what the Canapan group found made me excited to explore the implications for how galaxies evolve, Richardson said. Therefore, scientists took on the challenge of constructing a new census of growing black holes, with attention to both traditional and mixed message types. They obtained published measurements of visible light spectral features to test for black holes in thousands of galaxies, found in 2 surveys led by Canapan, Resolve, and ECO. These surveys include ultraviolet and radio data ideal for studying star formation, and they have an unusual design. Whereas most astronomical surveys select samples that favor big and bright galaxies, Resolve and ECO are complete inventories of huge volumes of the present-day universe, in which dwarf galaxies are abundant. It was important to me that we didn't bias our black hole search toward dwarf galaxies, scientists said. But in looking at the whole census, I found that the new type of growing black holes almost always showed up in dwarfs. I was taken aback by the numbers when I first saw them. So, more than 80% of all growing black holes she found in dwarf galaxies belonged to the new type. According to scientists, the result seemed too good. We all got nervous. They further stated, "The first question that came into my mind was, have we witnessed a way that extreme star formation alone could explain these galaxies?" So to find answers, they led an exhaustive search for alternative explanations involving star formation, modeling uncertainties, or exotic astrophysics. In the end, the team was forced to conclude that the newly identified black holes were real. "We're still pinching ourselves," Canapan said. "We're excited to pursue a zillion follow-up ideas. The black holes we found are the basic building blocks of supermassive black holes like the one in our own Milky Way. There's so much we want to learn about them." So now, although the basic formation process is understood, one perennial mystery in the science of black holes is that they appear to exist on 2 radically different size scales. On the one end, there are the countless black holes that are the remnants of massive stars. On the other end of the size spectrum are the giants known as supermassive black holes, which are millions, if not billions, of times as massive as the Sun. Astronomers believe that supermassive black holes lie at the center of virtually all large galaxies, even our own Milky Way. Therefore, the researchers researched their conclusion after conducting an exhaustive search for alternative explanations for these to be not black holes, but just young stars. However, as more data becomes available, astronomers hope to learn whether the shortage of little black holes points to some novel aspect of stellar physics, or if small black holes are in fact peppered throughout the galaxy, uncounted thus far because we've only just developed the means to hunt for them. So there are a lot of questions that need some answering, and scientists are hopeful that they will come up with something soon. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.